Hello, BNS 210. How's it going? I'm going to give you guys a couple PowerPoints on ANOVA tests. But first, I want to just do a brief introduction to ANOVAs and what types of ANOVAs we have. So just to review what we talked about the other day on the last PowerPoint, where we talked about main effects and interactions. I checked over you guys' worksheets and they all were pretty good. I didn't see any big major problems. Not everyone got all of them right, of course, but I didn't see anything overall that kept coming up that needed to be addressed. So that was pretty good. So remember, whenever we're talking about main effects and interactions, or when we're talking about an ANOVA test, we're talking about the main effects and interactions in particular are for factorial designs only, not single factors. So we are talking about factorial designs. So remember, if we have our most simple 2x2 design, we have two independent variables, we have four conditions. Each of our independent variables has two levels. We have three null hypotheses that we're testing here with the ANOVA. Our null hypotheses that we're testing is if there is a main effect of factor A. So our null hypothesis would be that there's no difference between the two levels of our first independent variable. Our other null hypothesis is that there is not a difference between the two levels of our second independent variable. And then our third null hypothesis would be that these do not interact, and we will not see an interaction between factors A and B. If we have a 2x2x2 design, think about that. We would have three independent variables, so we would be testing three main effects, and we would be testing four interactions. So how many null hypotheses would we have? 7. Very good. Okay, so this is the F test. So let's get into the ANOVA. The ANOVA is the F test. Okay, so ANOVA also stands for analysis of variance. So we're analyzing the variance within each of our independent variables and our interactions. So we are going to use it whenever we have a single independent variable with more than two levels, so our single factor multi-level designs, or whenever we're testing more than two independent variables, so our factorial designs. That's when we're using the ANOVA test. So this is how we're going to test what's known as complex designs or factorial designs. Okay, so when we're looking at the ANOVAs, the way you can determine what type of ANOVA you have is first you have to determine how many factors do you have. If you have a single factor, multi-level design, you're going to use a one-way ANOVA, one way for one independent variable. If you have two independent variables, it's called a two-way ANOVA. If you have three independent variables, it's called a three-way ANOVA, and so on and so forth. So then you have to determine whether your factors are within or between or some mixture of both. So go back to that worksheet that we worked on, and I'm going to add these to the worksheet for you. If all of our independent variables are between, we're going to use a randomized ANOVA. If they're all within, we're going to use a repeated measures ANOVA. And if we have some combination, it's going to be a mixed ANOVA. Now, the second thing we have to think about with our ANOVAs and what our ANOVA is how many dependent variables do we have? Do we have one? If it's just one, we're going to use a univariate ANOVA. That means we'll have one dependent variable. And if we have more than one, we're going to use a multivariate ANOVA. This is also called a MANOVA, which can be fun if you want to call it a MANOVA. Hang on, Josie, what? I'm recording a lecture.
We wanted to see that video you did.
Josie, later, okay? Sorry, guys. Okay, so let's do a little practice here. If we have a 2x3 ANOVA, and all of these are between subjects variables and we only have one dependent variable, this would be called, if I was to ask, what kind of ANOVA are you going to use on this? You would use a two-way randomized univariate ANOVA. If we had a 3x3x2 with some sort of mixture between and within variables, and we had three dependent variables, we would have a three-way mixed multivariate ANOVA, or a three-way mixed MANOVA. Let's say we had a 4x2 with all within subjects and just one dependent variable. It would be a two-way repeated measures univariate ANOVA. Okay, so now I'm going to talk about this type of ANOVA. You're not going to need to do this. You're not going to need to practice with this in our class, but I do want you to be aware of it. If you ever find yourself in a situation where you're doing a 350 project or something like that and you need to use one of these, I can help you with it. But this is called the ANOVA, also known as the analysis of covariance. So this is whenever you have one dependent variable, whenever you have a dependent variable and a categorical independent variable, along with a continuous independent variable. So most of our independent variables are categorical, like male, female, cocaine, saline, that type of thing. But a continuous independent variable would be what we normally think of as a dependent variable, but it could be something continuous that is an independent variable. So the best example, because I run these a lot in my research, so one example of this would be, say, plasma hormone levels. Plasma hormone levels are on a continuum, so this is a continuous independent variable. Josie, you need to give me some, okay, go grab it for me, please. So like plasma hormone levels, which is on a continuous independent variable, and then cocaine would be our categorical independent variable, and locomotor activity would be our dependent variable. So here we go. So our dependent variable would be locomotor activity. You can have more than one dependent variable, by the way, for this, but it's just the example. But when you have a continuous independent variable and a categorical independent variable, that's when you run the ANOVA, because the covariance is between the categorical and the continuous independent variable. Okay, and that's all for that. So I'm going to see what these kids want out here. And thank you for watching this video. And I'll be posting up more about the ANOVA, the F test, and how that's conducted later on. Thank you.